Certain times when we find the inverse of a function, the inverse itself is a function. Under what circumstances does this occur? Well, a function is going to be called one-to-one if the inverse of the function is also a function. A function is one-to-one if, for two different x values, the function must have two different y values or outputs. In other words, if x1 does not equal x2, then it must be the case that f of x1 does not equal f of x2. What we want to do is have an easy test for identifying one-to-one functions. An easy test for identifying one-to-one functions is the so-called horizontal line test. The horizontal line test states that if any horizontal line crosses the graph of a function in at most one spot, then the function is one-to-one. Let's look at a couple examples. What we have here is the graph of the function y equals x squared. What we should notice is that when I draw a horizontal line, the horizontal line crosses the graph in more than one spot. That means that this particular function y equals x squared is not one-to-one. Let's think about why this horizontal line test works. Remember, by definition, a function is going to be one-to-one if, when you have two different inputs, say -1 and 1, you must have two different outputs. In other words, you can't have f of 1 equal to f of -1 if you're going to have a one-to-one function. Well, whenever we draw a horizontal line, drawing a horizontal line means we're drawing a line y equals some value b. The y value represents the output of the function. So y equals 1 is an output, which is the result of two different inputs, which makes the function not be one-to-one. Down here we have the graph of the function y equals x cubed. What we notice here is that whenever I draw a horizontal line, the horizontal line can only intersect the graph of the function in at most one spot. Therefore, the function y equals x cubed is one-to-one.